going to discuss some of the basic terms in graph theory. Graph theory is the study of the relationship between edges and vertices. A graph consists of a set of dots called vertices and a set of edges connecting pairs of vertices. Vertex is a dot in the graph that could represent an intersection of streets, a landmass, or a general location like work or school. Vertices are often connected by edges. Edges connect pairs of vertices. An edge can represent a physical connection between locations like a street, or simply that a route connecting the two locations exists like an airline flight. So this is an example of a graph. So we can name this graph as graph G. Okay, and this one is a vertex. We have vertex B, vertex A, vertex C, and vertex D. Actually, our vertices are dots. However, I just use circle so that I can write the name of the vertex inside. Okay, but actually our vertices are represented by dots. So these are the vertices in this particular graph, which is graph G. So we have vertex A, B, C, and D. And these vertices are being connected. So vertex A and B is connected because of this edge. So we can name this edge as edge AB, and then another edge that is being connected A and B is vertex A and C is being connected using this edge. So we can name this edge as AC. Then another connection for vertex C and D. So we can name this edge as CD. So this edge is edge CD. And finally, vertex B and D is being connected by this particular edge. So we can name this edge as edge BD. So here is an example of where we can use the concept of graph theory in real-life situation. Okay, so particularly the graph, okay, the definition of a graph and the use of edges and vertices. So the vertices here, they are represented, they represent some of the popular places or popular area. Okay, like for example, we have the KCC. Okay, let's say we have the KCC, we have the Jollibee, Union Bank, a dress shop by Lorna, and Ateneo de Zamboanga University. So it is being represented by particular or by corresponding vertex, and the connections between these popular buildings or popular area, the connections are being represented by an edge. Okay, it may be a street, it may be a pathway in between. So we have KCC Mall going to Jollibee Camins. So there is an edge here, and then another edge or pathway. I think this is pathway or a street, no? A street from Jollibee Camins going to Union Bank, and then Union Bank going to Lorna's dress shop, and then a street or pathway from Lorna's dress shop going to the Ateneo de Zamboanga University. Okay, so this is how we can use the concept of graph in real-life situation. Now, in graph theory, it is important that a graph is determined only by its set of vertices and set of edges. And we do not care about which vertices are connected to each other. So, for example, we have these two graphs here. As you can see, in geometry, we will identify this graph as square. Okay, so this is a square. This is in geometry. So we identify this figure as square and this figure as triangle. But in graph theory, both figures, okay, or both graph is the same. Both graph is the same. Okay, as long as the connections between edges are the same. For example, in here, A is connected to C. So same as here, A is connected to C. A is connected to B. A is connected to B. C is connected to D. C here is also connected to D. B is connected to D. Also here, B is connected to D. So as you can see, in graph theory, the only important thing is the connections between the vertices and the edges. So it doesn't matter as to what will be the figure is. Okay, just like in our example, although in geometry we identified them as different because this is a square in geometry and this is triangle in geometry. But in graph theory, both graphs is considered to be as the same graph. Okay, so let's say we will name this graph as graph G. So this one is just the same as this. So if this is graph G, then this is also graph G. So this is a loop. Okay, this one, the right one. Okay, so this is a loop. It is a special type of edge that connects a vertex to itself. Loops are not used much in straight networks graphs. Okay, so this is a loop. Okay, let's say, and this one is a vertex. So let's say we will name this vertex as vertex A. So let's name this as vertex A. So vertex A is connected to itself. Okay, so let's say, you started at A, then you go using this edge, you walk around going this using this edge, okay, and then you will go back to vertex A. Okay, so that is a loop. That is why it is said that the loop is we do not use the loop in straight network graphs. Because in reality, our streets, it's very often that we see a street that is in a loop way, like this. Okay, we do not see any street like this. Okay, we usually see as a street that is a straight way. Okay, straight. Now, what is the degree of a vertex? The degree of a vertex is the number of edges meeting at the vertex. It is possible for a vertex to have a degree of 0 or larger. For example, we have here degree 0 because the vertex does not have any edges that is incident to it or connected to it. None, 0. In here, the degree of the vertex is just 1 because there is only one edge that is incident or that is connected to this vertex. This one has degree 2 because there are two edges connected to this. Here, this vertex has degree 3 because there are 3 edges that is connected to this vertex. And of course, this vertex has degree 4 because there are 4 edges connected to this vertex. Walk. A walk in a graph G is an alternating sequence of vertices and connecting edges in G. A walk is any route through a graph from vertex to vertex along edges. Okay. Now this one, this is an example of a graph. Okay, of a graph. Now, what is a walk? A walk, based from its meaning, based from its word walk. So we will walk from vertex to vertex. Okay, so for example, we will start at U. So we will start at U, then we will walk towards V, then we will walk towards W. We can stop at W if we want to. Okay, we can stop at W. So we walk from U to V, then V to W. Or you wanted to continue, so we will walk from W to X, then X to Y, and Y to Z. Okay, that's it. We will walk. So the walk on the given illustration, so if we want to continue, if we want to walk from vertex U to Z, then our walk is UV. Okay, so UV, then VW, then WX, XY, then YZ. Or we can just simply denote the walk as UVWXYZ. So that is our walk. Now, it is not required for all the vertices and edges in a walk to be different. A while ago, we walked from U to Z. And then, so we walk from U to Z, so we walk U, V, W, X, Y, Z. Now, if you have observed, when we walked from vertex U to vertex Z, we did not use any of the vertices and edges twice. Okay, we only used the vertex and the edges. We passed by the vertex, the vertices, and the edges once lang. And we did not go back. But it doesn't mean that that's it, that we cannot go back, that we cannot use the vertex, that we cannot pass by the edges anymore. We can pass, or we can use the edges, we can use the vertices as many times as we want. For example, so let's say we have this graph, okay? And then we want to walk from, so here is our walk. So we want to walk from U, going to V, going to Y, then X, then W, then V again. So as you can see, we pass by V again, the vertex V. And then we want to go to Z, then Y again, then W, then V. So as you can see, we pass by some of the vertices twice and some of the edges twice. Okay, so it's okay. It's okay for the walk. It's okay for us to have this kind of walk, that we will use the same vertex, the same edges more than once. And then a closed walk, if the starting and end vertices of a walk are the same. So if we make a walk in which we started on a certain vertex, then we end up in that vertex, then it is a closed walk. It is a closed walk. So let's say, for example, we have this from U to Z, Z to Y, Y to V, Y, V to Z, then we go back to U. So again, we started at U and we end up at U. So that is a closed walk. A path is a walk that does not include any vertex twice, except that its first vertex might be the same as its last. Okay, so a while ago, in walk, we were able to use the vertex more than once. Ginamit natin yung sum of the vertex sa walk ng 2 beses, ng 3 beses. We can do that in the walk. But in the path, we cannot use the vertex more than once. Okay? Hindi natin pwedeng gamitin ang vertex ng, pwede lang natin gamitin ang vertex ng isang beses lang sa path. Pero sa walk, pwede natin gamitin ang vertex more than once. Kahit ilang beses natin gamitin. Kahit ilang beses natin pupuntahan yung vertex na yon. Okay? But sa path, isang beses lang natin pwedeng gamitin or isang beses lang natin pwedeng daanin. Okay? So, for example, this graph. So, ang path natin, okay. By the way, this is just one of the many paths. Pwede tayong gumawa ng, pwede tayong mag-name ng any path or mag-identify ng any paths here. Okay? Marami pa yan, hindi lang ito. This one is just an example. So, I can determine a path here starting sa V. So, I'll start here, V, then W, then X, Y, then Z. Okay? So, as you have observed, hindi tayo dumaan sa vertex ng 2 beses, 3 beses. Instead, dumaan tayo sa mga vertex ng isang beses lang. V, W, X, Y, Z. Okay? Ang importante sa path, isang beses nyo lang pwedeng gamitin ang vertex. However, ito yung exemption. Cycle or circuit. From the word cycle, pag sinabi natin cycle, di ba para siyang circle? So, a cycle or a circuit is a path that begins and ends on the same vertex. So, kung saan tayo, remember, this is a path. Ibig sabihin, once lang natin pwedeng gamitin ang vertex. Pero, since this is a circuit or a cycle, ibig sabihin, kung saan vertex tayo nag-start, dun din tayo mag-e-end. So, for example, this one. Okay? So, we started at V, going to W, then X, Y, Z, then bumalik ulit tayo sa V. Okay? So, bumalik tayo ulit sa V. So, the only vertex na twice natin ginamit is yung V, which is the starting and end vertex. So, here is another example. So, in this graph, we have path A, B, F, G, H, M. So, again, we only use the vertex once. In here, we have circuit A, B, F, G, L, K, J, E, A. So, we use the vertices only once except for A, because we started at A and we end up at A. Okay, now, kanina sa path, we can use the vertices once lang, isang beses lang. Except lang sa cycle or sa circuit because there is one vertex there na pwede natin gamitin ng twice because we will start at that particular vertex and we will end up to that particular vertex din. That is path. And sa path, ang pinaka-importante is yung vertex lang na dapat hindi tayo pwedeng gumamit ng vertex more than once. Pero yung edges, no, yung edges pwede nating gamitin ng ilang beses natin gusto. Okay? Dito naman sa trail, kabaliktaran. We can use, we will only use the edges once. Okay? Isang beses lang natin pwedeng gamitin ang mga edges. Pero ang vertices, kahit ilang beses natin pwedeng gamitin. Okay? Kahit ilang beses. Yung sa vertex. Pero ang edges dito sa trail, isang beses lang. So here is an example of a trail. So again, a trail is a walk. Okay? A trail is a walk that does not pass over the same edge twice. And it is not necessarily all the vertices is different. So here is an example of trail. So we will start at V, then Z, V, then Z, then there is a loop. So we will use the loop, okay? Again, V to Z. So ibig sabihin, okay, so it means nagamit na natin itong edge. Then yung Z, Z again. So ibig sabihin, we will use this loop. Okay, and then from Z, we will go to Y, so we will use this one. And then from Y, we will go to W, so we will use this edge. And then from W, we will go to X, so ibig sabihin, we're going to use this edge para pumunta sa X. Then from X, we will go to Y, so we will use this edge to go to Y. So we end up here. We started at V, and we end up at Y. So as you can see, in here, we use the vertex Z twice, and we use the vertex Y twice din, dalawang beses. Kaya, but still, this is a trail because we only use the edges once, itong mga nakared. Okay? We only use the edges once lang natin nagamit. Kaya, this is still a trail. Okay? This is still a trail. Kahit na merong mga vertices na dalawang beses natin nagamit. And then, we call a trail as closed trail or tour if yung trail na yon ay we begin and ends on the same vertex. So for example, so katulad lang ito sa circuit or sa cycle in which isa siyang trail pero we started at a particular vertex and we end up to this particular vertex. So kagaya nito, we started at V, tapos pumunta tayo sa Z. Okay, let me just erase this one. I will just use another color. So from V, we went to Z. Then from Z, we went to Z again. Then from Z, we went to Y. Y to W. W to X. X to Y. Then we go back to V. So we started at V and we end up at V. But still, this is a trail. Okay, it is called tour. Okay. Tour is a trail. So, kailangan, ibig sabihin yan, gagamitin natin yung mga edges isang beses lang. Okay, isang beses lang. Okay, so length. A length of a path is the number of edges in the path. So, for example, in this one, the path here is path A, B, F, G, H, M. Again, the path here is path A, B, F, G, H, M. And in this particular path, it has a length of 5. A length of 5 because we used 5 edges. No, we used 5 edges for this particular path. So we have 1, 2, 3, 4, 5 edges. A connected graph and a disconnected graph. So this is an example of a connected graph. Why? Because there is a path, meaning we can travel from one vertex to the other vertex. Okay? So meaning may mga edges tayong pwedeng puntahan para mapuntahan natin yung particular vertex. Now, not necessarily na we have this one. Kahit wala ito, kahit yung parang square lang, okay na yon. Still, it is a connected graph. Why? So let's say this is we'll start at this vertex. Then we wanted to go in this vertex. So, let's travel. Start tayo dito, going here, then going here. Kasi nga may edges. May edge tayong nagko-connect from here, then to here. Then, let's say we'll start here, then we wanted to go there. So, start tayo dito, then go here, then there. So, kahit wala itong diagonals, okay lang. Still, this is a connected graph. Now, in this one, this is not a disconnected graph because nga, from the term itself, disconnected. So, walang nagko-connect. Okay? For example, this particular vertex. At gusto kong pumunta dito sa vertex na ito. So, paano ko gagawin yun? Wala namang road, no? Kung sa real life situation pa yan, walang road, walang street, walang pathway na pwede natin gamitin para makapunta tayo dito. Okay? So, walang nagko-connect in any of the vertex dito sa particular graph na ito. Okay? So, wala. So, ibig sabihin, with this, no, this is a disconnected graph. Weights. Weights, these are numbers that are assigned to the edges. So, for example, ito, NB, the vertex NB going to vertex Y. Itong mga letters na ito, we can, maybe ang mga vertex dito, nagre-represent sila ng mga places. Okay, ng mga places or locations. Okay, so we have T, A, N, B, Y, M, R, P, and E. So, I think these are places. And then, itong mga numbers na ito sa edges, they are represented by siguro travel time or travel cost. Okay? Pwedeng travel time, pwedeng travel cost. So, yan yung function ng mga weights. Itong mga numbers dito sa edges, yan ang mga weights. So, pwede yung travel time. Okay? Ang ibig sabihin yan, it represents travel time, travel cost, or distance ba? Distansya. So, let's say, for example, from NB to Y, ang distansya niya ay 10 kilometers, no? For example, ng 10 kilometers or 10 miles. Okay. So, yan ang ibig sabihin ng weights. Weights in a graph yun. Weights in a graph. Okay. Now, this one is called simple graph because it has no loops. Natatandaan niyo ang loops, okay, in which it is an edge. Okay, isa ito, ang loop ay isang edge kung saan yung endpoint niya ay pareho. Endpoint ay pareho. Nag-start tayo dito, tapos dumaan tayo sa edge. Okay, start tayo dito, tapos dumaan tayo sa edge, pero bumalik pa rin tayo dito sa vertex na ito. So, ganun ang loops. Pero in this particular graph, wala siya nun. kaya it is called a simple graph. Dito naman, this is called a graph with multiple edges. Okay, if two vertices are connected by more than one edge. So, ito yun. So, itong dalawang vertex na ito, dalawang vertices na ito, ang nagko-connect sa kanila ay dalawang edges. Dalawang edges. This one and this one. So, we call it a graph with multiple edges.